Hello all, I'm Jyothi, Assistant Professor, Department of ECE NCET. So today I'm going to explain you about the pulse code modulation and detailing about the pulse code modulation. So now we will be discussing about the pulse code modulation. Now we know that the modulation is nothing but the conversion of the data into the radio waves by a little addition of electronic or optical carrier signal. So in the pulse code modulation, if we have to define the pulse code modulation, it is nothing but conversion of the analog signal into the digital signal so that the modified analog signal can be transmitted through the DC communication or a digital communication network. So here we have the first block diagram has a transmitter, then the transmission channel, then comes the receiver part, then there is a regeneration circuit. So we'll be explaining now about the transmitter part. So as we know, the analog signal here is sent into the low pass filter. So we know that the low pass filter is nothing but it will attenuate or we can say that it will remove the high frequency components that is present in the analog signal, that is say we are taking g of t. So the low pass filter, it will attenuate the high frequency components which is present in g of t, which is not required for the representation of the g of t. So once the analog signal is sent into the low pass filter, the low pass filter will strictly band limit the analog signal and then it is sent into the sampler and quantizer. So the source information here, you can say it as a source information. So here it is sampled and quantized into some of the L levels. So I'll say what is sampler now. We know that sampling is nothing but it is a conversion of or you can say the reduction of continuous time signal into the discrete time signal, whereas the sampler is a subsystem or an operator in that, where it will extract the samples from the continuous time signal, and then the sampled, once the analog signal or the source information is sampled, it is sent into the quantizer. So quantizer, it is nothing but the quantization takes place there. So here we can see that it is mapping of infinite continuous values into the discrete finite values. So in the simple words, if we say, quantization is nothing but mapping the real numbers with the integers. We have some analog signal here. You choose few points on this analog signal and take those few points from the analog signal and round them off to some stabilized value. So quantizer, once in quantizer, it will take the each sample value and it will round off to some quantization level. Now, once this information is sampled and quantized, it is encoded into a n-bit code word. So here, when it is encoded into a n-bit code word, the number of bits in the code word should be relatable to the number of quantization level. So at this point of time, what happens to the information is nothing but the binary levels are coded, or various binary levels are encoded here. When the various binary levels are encoded into the encoder, that is encoder, what happens is it is basically a binary digits which is transformed into the electrical waveform. So in the encoded part, you can see there are binary digits which is represented into the electrical waveform by 2 points, that is non-return to 0 unipolar waveform, and we have another point as non-return to 0 polar waveform. So that is the binary digits which is represented by the electrical waveform is in two parts, that is non-return to 0 unipolar and the polar waveform. So once the samples are encoded, we get the PCM wave which will be sent into a communication channel, that is next part of the block diagram, which is the transmission route. So once this PCM wave is sent into the communication channel, or when the PCM wave is propagated into the communication channel, there is a distortion. So the main reason for the distortion here would be the non-ideal transfer function of a transmission medium, or the unwanted noise or the unwanted interference will cause this PCM wave to get distorted. Therefore, this distorted PCM wave, instead of continuing further or continuing into rest of the blocks, it is sent into a regeneration circuit which I have drawn here. So the regeneration circuit consists of amplifier, equalizer, decision making device, timer circuit, and then a regenerated signal. So once this PCM wave gets distorted here in the communication channel because of some unwanted noise, it is sent into a amplifier equalizer. So what does the amplifier equalizer do? There is nothing but it will compensate, it will shape the received pulse or received PCM wave, it will shape it or reshape it, and then in amplifier equalizer it will compensate the effect of amplitude and phase distortion. So once the output of the amplifier equalizer is sent into a timer circuit here, this timer circuit will produce some train of pulses, okay, which is known as a sampling waveform. Using that sampling waveform, output of the amplifier equalizer can is sampled at different sampling instance, and then the sampled value whatever we have got, if it is greater than the preset threshold value, so there will be a threshold value already which is set. So once the amplifier output of the amplifier equalizer which is sampled using the sampling waveform, the sample value if it is greater than the preset threshold value, then the decision making device is enabled, or else when it is enabled, the next pulse is sent into the repeater again. But if the sample value is lesser than the preset threshold value, then the decision making device will be disabled, and then we get a regenerated signal if it is greater than preset threshold value. Now this regenerated signal here is an input to the regeneration circuit. Okay, so the output of the regeneration circuit is given to the decoder. In the output of the decoder we can see obtain a staircase waveform which is then converted into a smooth waveform by a reconstruction filter, so which will improve the efficiency of a signal. Thank you.